Okay. So on this first one, for 6, what'd you get? Anybody got anything else? Oh, just guessing. You're guessing. Okay. So on here, it says Sarah uses an activity tracker with records, which records the number of steps she takes daily. On Monday, she walks 14,563 steps, which is in the 65th percentile of the distribution of the number of steps she's taken on all other days. Which of the following is a correct interpretation of this situation? Okay, so looking at A, it says the number of steps Sarah took on Monday is less than or equal to 65% of the number of steps she's taken all other days. Is that true? I'm asking.
Yes.
Say it one more time. Okay. Why do you say that?
About percentile, it's talking about everything else being less than, like in test scores, the SAT, it would be like 80th percentile because you were better than 80.
Okay. What about B? Sarah takes at least 14,563 steps. No, why?
Percentile.
Okay.
This is happening.
All right, what about C? The number of steps Sarah took on Monday is 65% greater than the number of steps she's taken on all other days. Most of y'all put this, right? What's the difference between this one and this one?
Because the bottom line says greater than or equal to, which is what a percentage. It's not just greater.
So if it's 65% greater, it's multiplying that score, like, you know, everything else is divided. It's 65 instead of it being the actual percentile.
Okay. And then D says Sarah is 65% more likely to walk at least 14,563. Is that what a percentile is? No. So the answer is, yep. Why A is wrong. The number of steps Sarah took on Monday is less than or equal to 65% of the number of steps she's taken on all other days. Victoria, you want to describe why it's greater than, not less than?
Steps. Because the percentile talks about how it is better than other scores, we would describe all the other days as being less than 14,563. But the score itself is greater than the rest of those scores. And since the A is talking about how many steps you took on Monday being greater than or less than, how many steps you took on Monday is greater than everything else. It not less than everything else, because everything else is less than the steps you took on Monday.
No, but you good?
Monday greater than every other day. Well, 65% of every other day. Greater than 65% of the days.
Yeah.
Yeah.
So she's saying that the 14,563, the number of steps she took on Monday, is greater than all the rest of the other days. 65% of all the other days. Yeah. This guy's bigger. Yeah. It's kind of like when I say I'm in the 90th percentile of people who took the SAT. So that means that I'm better than all these other ones. Does that make sense? Okay. Let's go number 7. Cumulative relative frequency graph shown reports the daily amount of grams of protein consumed by a sample of 50 healthy adults. For a healthy adult, it is recommended that 10% to 35% of the recommended daily calories come from protein, which is anywhere from 50 to 175 grams of protein daily. What percentage of adults in the sample consumed the recommended amount of protein? Say it again. D. How do we get that?
I just made a mark where the minimum amount is and the maximum.
These going up by 10, 60, 70. 75, so like right in here somewhere. Okay. And you went from
They, like the lower part, they're gonna be 15%. And then the thing that that's not there. So then add 15,
So
20.
15 and what is this one?
Well,
Like 5 is higher than, you know.
Mm. Okay, so what's the difference between these two?
We're supposed to add those.
Right.
Yeah.
add those two and subtract this amount.
Okay, so she said 15 plus 5 is 20. That's what's not included in this range that they were talking about, right? So then 100 minus 20 is, yeah. Okay. Good?
Yeah.
Okay, can we do our checker, your understanding? Go to your check. Okay, so the distribution of waist circumference for women who are 8 months pregnant is approximately normal with a mean 44 inches and the standard deviation of 4 inches. Just a reminder, if you were not here yesterday, this is a little symbol for mean. This is a little symbol for sigma or standard deviation. Not the giggling again. Label the mean and the values that are 1, 2, 3 standard deviations from the mean. So the first thing that you're going to do is you're going to draw an awesome curve. You're going to draw a straight line down. What's the mean?
44.
Okay, cool. Then what you're going to do is the standard deviation is 4. So you're going to add 4 multiple times. Ooh. Are you not supposed to what? You are.
Oh.
Mine is janky. It is on this thing. Just let me live my best life. Okay. All right. And we're going to add 4 onto it. And then we're going to subtract 4. So going the other way. Okay. And then we're going to label these percentages inside. Yesterday we talked about this. You want to make sure that you have these numbers either memorized or just use them so much that you have them down. Okay. We expect you to know this. You need to look back on your formula sheet and see if that has it on there, but I don't think it does. I think it's just algebra 2. Okay. So you fill in all that information. Questions on that? Okay, notation that you're going to see often is this. It's going to say in 44, comma 4. And what this means is the normal mean is 44 and standard deviation is 4. This is just like shorthand for here's a normal curve. This is the breakdown. Cool. Questions on that? You've got to be able to draw a normal curve. This is an algebra 2 skill. So at this point, you should be able to do it. You have a lot of people writing those, so I'm nervous. Okay. On part B, a waist circumference greater than 52 inches may indicate excess amniotic fluid. What percent of women who are 8 months pregnant may have excess amniotic fluid? How would we solve this?
You go to 52.
Okay.
And you put it to the right side.
Okay. Okay.
You get 2.5%.
Okay. So he said at 52, we're going to look what's greater than that. That's 2.35 plus 0.15. And that's going to give us 2.5%. Everybody good on that? Okay. About what percent of women who are 8 months pregnant have a waist circumference between 36 and 40 inches? 36 and 40 inches. How much?
13.
Okay, 13.5. It always helps me to just draw the curve and then kind of go from there. Yeah. So when you get like a normal distribution curve, and it'll say draw the normal curve that approximates the distribution. Okay. Or it'll say approximately normal. That's when you know to draw the normal curve. Cool. You cannot say normal. You have to say approximately. There's that LY word. Yes. Okay. Go ahead and flip the page. We're gonna go ahead and knock out our notes. Yeah. Yeah. Okay. So how many people you get two choices, Taylor Swift or Ed Sheeran? Okay. You gotta pick. All right. How many like Ed Sheeran better? How many y'all like Taylor Swift better? How many y'all really don't care? Yeah. Okay. Same. Actually, I like Ed Sheeran, and there's some Taylor Swift songs, but like I know Taylor Swift from back in like what 2009-ish, where she was like singing Teardrops on My Guitar. Like that's the Taylor Swift I know. Okay. Yeah, the country version. Yeah. I like OG Taylor Swift. All right, so an analysis of the top songs on Spotify over a 10-year period reveals the song links follow an approximately normal, there's our fancy words, approximately normal distribution with a mean of 220 seconds and a standard deviation of 26 seconds. Label the appropriate values on the normal distribution. 220? Okay, interesting. Label the appropriate values. So what's the first thing you're going to put on your approximately normal distribution? 220, because that is the mean. So 220 is going to go in the middle. Okay, then what we're going to do to get the other numbers down at the bottom. Add and subtract 26. So let's go ahead and do that now. So that's 246, 272, 298, and then we're going to subtract 194, 168, and 148. Yes. Okay. All right, what percent of song? Oh, we got to fill in the other data. I would go ahead and put the empirical rule in here. So this is 68% of the data. This is 95. And 3 standard deviations is 99.7. All right, what percent of the songs are longer than 246 seconds? 16%. Sometimes you can do this a different way. I don't like this way, but I'm going to show it to you anyways. All right, so a whole curve is 100%, right? Okay, if we subtract 68, that gives us 32. And 32 divided by 2, because we have two sides to the normal distribution, would give us that 16%. I'm not a fan of that. Yep. That's a good question. It's a good question. Empirical rule, this covers that 68% here. Okay, so that means that there's 32% over here, right? And we divide, I'm sorry, there's 32% on the outsides of those. And then we divide it into 2 to give us this information. I think it's goofy. I don't like it. Draw your curve and go from there. Cool? Okay, cool. All right. Number 3, what percent of the songs are between 168 and 246? Okay, so 168 to 246, you're just going to add up the totals that are in here. So that's 34 plus 34 plus 13.5. Okay, so 34 plus 34 plus 13.5, and that gives us 81.5%.
I was trying to write on the bottom of the wall.
All right, looking at number 4. What percent of the songs are shorter than 168 seconds and shorter than 194 seconds? Good. Okay, so coming down here. I want to keep my curve though. Okay. So we said, oh, I'm going to have to get rid of it. Sorry. All right. What percent of songs are shorter than 168 seconds and then shorter than 194? For 168 seconds, that's 2.5%. Everybody okay where I got that from? Okay. And then for 194, that's going to be 16 seconds. Again, everybody okay where I got that from? Okay. Again, this is algebra 2 skill, kind of roughly easy. What percent of the songs are shorter than 181 seconds? How would we go about doing this? Okay. But it's not going to be exact according to our curve, right? Okay, so this is where z-score comes in. You ready? Do you remember your formula sheet that you got like on the first day of school? I would take that out. Yeah. You're gonna flip to this page. Yeah. Do we remember this? Yeah, we love and hate it all at the same time. Okay, so everybody ready? Ready. Here's the math. Okay, so yesterday we learned about z equals the value minus the mean divided by the standard deviation, right? Yes. Okay, so what's our point? 181. What's our mean? 220, right? Okay, and our standard deviation was 26. Okay, when we put that into our calculator, what do we get? What do we get? What's up?
Is that like my Z?
Yeah, my Z's have the little line through it because otherwise it looks like a 2.
Is that like the sign for Z score? Or like,
No.
so you start to like write Z score?
Just Z. Z is fine. Okay, what'd you get for this? Try again. 181 minus 20 divided by 26. I got negative 1.5. Okay, cool. It's okay. Make sure you use parentheses in the top. Maybe. Okay. All right. Now, what you're going to do, that's a negative. So we're going to go to our table that has negatives on the side. There's a table that has positives and there's a table that has negatives. You're going to go to the negative table. Okay. Then what you're going to do, our z-score was negative 1.5, right? So we're going to look on this side and we're going to look for negative 1.5. What's the next number in this decimal? 0. So we're going to go down to negative 1.5 and we're going to go over to 0. And we get 0.0668. We're going to change that to a percent. Ta-da! I know. So if you can't find something using the normal curve, you use z-score and then you use the table to find your percent. Does that make sense? Okay. Biggest error that people make in this is they just don't pay attention. They write down the wrong percentage. Okay. Or they use the positive versus the negative. Okay. It's important. It matters. Cool? Okay. Go and flip the page. Huh? All right, go and go to the next page. All right, so Ed Sheeran and my girl Beyonce made the list with the song Perfect Duet. Have y'all heard that? Yeah, I like it too. All right, which is 260 seconds. What proportion of songs are longer than Perfect Duet? Okay, so what we're going to do is we're going to say z-score equals the value minus the mean divided by the standard deviation, right? What's our value? 260. What's our mean? And what's our standard deviation? Okay, when we plug that in, what do you get? 1.54. And then we're going to go to our fancy table, right? We're going to go to our table, and are we going to use the positive or are we going to use the negative? Positive. So we're going to flip to the next page. We're going to go down on the left-hand side and find 1.5, and we're going to go over to 04 and help me because I'm blind. I think it's 0.9382. 0.9382. Here is the problem. Look at this graph. Look at this normal distribution. Do you see how the bottom is shaded? That's less than. What was the question actually asking? Greater than, right? So we're going to do 1 minus 0.9382. If it would have said less than, we would put 0.9382. But since it says greater than, we're going to do 1 minus 0.9382. So 1 minus this. What does that get me? Okay, so the area under the curve is 0.0618, which is 6.18%. Yeah. Yeah, I did put a period on there. I like me. All right, so for those of you who are visual people, that means that we're doing our normal distribution curve. Okay, in the middle, we got 220. We're trying to find 260 and above for the normal distribution of 220 with a standard deviation of 26. Another way you could probably see this, I'm just throwing this at you, okay? You might see this normal curve like this. The mean is 0, and we're finding 1.54 and above. Why would we put 1.54? Remember yesterday how we talked about standardizing all of the stuff? The mean was 0. Standard deviation was 1. Yeah, that's what this is representing. Now you could see this like this, where we had the mean of 0, standard deviation of 1. This is standardizing things. Make sense? Okay. All right, let's look at the next one. Taylor Swift has many songs on the list with widely varying song lengths. We Are Never Getting Back Together is only 193 seconds long, while Endgame is 245. What proportion of songs are between these two song lengths? Okay, so what you have to do is find the z-score for both, find the proportion for both, and subtract the two. Okay, so go ahead and find the z-score for each one of those songs. So 193 and then 245. Okay, we're going to look it up on the table, write it down, subtract the two. Same, homie. I'm going to start playing the Taylor Swift GOAT song list. Those are funny. I like it. Escape. Okay, so your z-scores were negative 1.04 and positive 0.96. So go to your table and look up the proportion for negative 1.04. Negative 1.04. So you're going to go to the negative page. You're going to go 1.0, go over to 04. I get 0.1492. 0.1492, yes. Okay, and then you're going to go to the positive page. And you're going to go 0.96. So down 0.9 over to 06. That's 0.8554. Correct me if I'm wrong. Gucci? 0.8554. Okay. So now that we've got those two proportions, what we're going to do is subtract them. Yay. Okay. So going back to my other page. You're going to subtract those two. So you'll get 0.8554 minus 0.1492. And what does that give us? What? It might be. Yeah, what's up? So when you look at your table, you get 0.8315. Okay, cool. All right, so 0.8315 minus 0.1492. And what do you get? I got 68.25. Yeah. Yeah, it should be 2.3. Everybody okay? Nothing crazy? Okay. Number 8. Many artists are paid on the streaming platforms according to how much time people listen to their songs, which encourages them to make longer songs. How long should an artist make a song if they want to be in the top 10% of the longest songs? Go ahead and take a moment. Look. All right. So how are we going to go about doing this? Do we know the value? We don't know the value, but we know the percentage, right? Okay. So we want 10% of the longest songs, right? So my visual people, we're talking about normal distribution and we're trying to say 10% up here, right? I'm sorry, we're trying to find the proportion for that guy. And we want the top 10%. Okay, this area right here is 0.1. Okay, so if we go into our table and we look for 0.1, and then we find the z-score, we can work our way backwards. Okay, yes? Okay, so go back into your table. We're looking for 0.1 inside of this. Okay, now we want greater than. So what number are we actually looking for in this table? Let me say it again. When you look up these numbers, we're looking at less than. We want the opposite. We want greater than 10%. So what is 1 minus? Go ahead. Okay, so 1 minus 0.1, right? Which is going to be 0.9. So in here, we're looking for 0.90. Okay, so really quick, look down in here. 0.90 is like right in here, right? It's in between these two things. 0.90. So we're going to say 1.28 because that's closest to 0.9 without going over, right? Do we see where I'm getting that from? I got some confused faces. Okay. We want 0.90, right? There's not exactly 0.90 in this table, right? Okay, so looking at our options, we have right here to right here. So somewhere in between here would be 0.90, correct? Okay, what is the z-score that's corresponding to that? Go ahead. This is the z-score. We don't have the z-score. We have the proportion. Yeah? We good? Inside the table is the proportion. The outside is the z-score. We don't have the z-score yet. Okay? So we're going to use a z-score of 1.28. With me? Still having confused faces. Are we okay? Okay. So coming back in here, if we have a z-score of 1.28, we're going to set that equal to x, which we don't know the value yet, minus our mean, which is 220. Standard deviation is 26. Now we can solve for x, right? Okay, so what are we going to do first? Okay, and then we're going to add 220. Okay. So x should equal 253.28 seconds. Check and make sure that's right. Okay. All right, for my people who like to follow steps, what we did here is we found the proportion. Inside the table. Found the z-score. Then we plugged into formula. Solved for value. Okay. Questions on that? All right, go ahead and flip the page. Go ahead and do the check your understanding. Very similar to what we just did. Okay. Go ahead and do the check your understanding on the next page. I'm gonna go through kind of like reminders that we learned. Okay, so oh my goodness. Okay, so find a proportion. This is how we did it. We found the z-score and then we used the table. I want you to write down normal CDF because eventually I'm going to teach you how to use a calculator to do all this stuff. Yay, calculators. And that way it's a little bit more accurate than actually using the table. But you got to know how to do both. Okay. For finding a boundary value, so that's kind of like we're given the proportion and now we're going to have to work backwards to find the value. You're going to use inverse norm. Again, I'm going to show you how to do that with a calculator. Okay. So for finding the boundary value, you find the z-score for the given proportion. You plug it into the equation and solve for x. Okay, these are just reminders of the last couple of things we've been doing. I'll give you a minute to finish writing that down. Okay, so for A, what percent of people take longer than 300 milliseconds to complete the task? That should have been 37.45. Does anybody need me to work that out? Okay, let me go through it really quick. So we want longer than 300 seconds. So we're going to say, this is up here. Okay, 300 minus, what's our mean? 284 divided by 50. That's going to give us 0.32. We're then going to go to our table and we're going to go down to 0.3 over to 0.2. And that's going to give us 0.3745. Okay. All right. On the next one, it's working it backwards. So you're finding the value. The value should have been 167.5. So I need to go through that one. Yes. Okay. I'm gonna give it a second because it was still writing. Okay. If I say 1%, what does that change into a decimal? 0.01. So I'm going to look in my table for 0.01. Look in your table for 0.01. And then you're looking for the corresponding z-score. It's going to be on your negative table. Okay, so we're talking about C. With C, you're changing that percent to a decimal, which is 0.01, and then you're looking in your table for 0.01. Tell me the z-score that corresponds. I have way too many tabs open. Yeah, there we go. All right, so we're looking for 0.01. So we're going to be on the negative. If we look right here, do we see it? The 0.0099. That's close to 0.01, right? Yes. Because we're looking for the proportion in here to be 0.01. If you look at the positive, it's like big numbers, right? This one has the smaller numbers. Yep. We okay? So our z-score on that one is going to be negative 2.33. Everybody see it? Yes, no, maybe. Okay. So then what we're going to do is we're going to go back in and we're going to say negative 2.33 is equal to x minus your mean divided by your standard deviation. And then we're going to solve for x. So we're multiplying by 50. We're adding 284. And that's going to give us x is equal to 167.5 milliseconds. Always put the units. Oftentimes we get to the end and we're like, yes, I got a number. You got to put it in context. Okay? Make it make sense. If it's a percent, put a percent. If it's a value, you got to put the units. Questions? Okay, what would this normal distribution curve look like? Okay, so what it's asking for is 1%, right? So we're going to draw our curve. You always have to put the mean. We don't know the value yet, but we know that it's less than 1%. When you draw your curve, you need to make sure that you say, hey, here's the mean, and the standard deviation is 50. So if they ever ask you to draw like a normal curve with this, that's what you do. Like a little sketch of it, it's there. Good. We okay. More practice. More practice. Good. Go ahead and flip the page. Okay, your turn. So, I always mess up his name, Jarinski, spends a full day at Gingerman Raceway testing some of his new tires on his Honda Civic. Mr. Jad does not drive a Honda Civic. Okay, for 400 laps, he records his lap time in minutes. At the end of the day, he plots the distribution and realizes that it follows an approximately normal, keywords, with a mean of 1.84 and a standard deviation of 0.07. Okay, your job is to do the rest of these. So fill in the curve, label all of everything, okay? And then go ahead and answer those questions. You can go ahead and also do the next page. Okay, so the next page is going to ask you to use your table. The front page is using the empirical rule. So that's that 68, 95, 99.7 rule. Okay. The next page is using that, what we just worked on. Don't do number 10 yet. I haven't taught you the calculator way yet. Okay. Go ahead and take a moment. Do 1 through 9. We're going to take, could y'all get that done in like 15 minutes? 20 minutes. Got it. All right, cool. All right, go ahead and get started. Yes. Yes, you may. Sign up. So when you label all this mess, Okay, you should have gotten 1.84, 1.91, thank you, and 1.98, and 2.05, and 1.77, and 1.70, and 1.63. Okay, we're gonna say this normal distribution has a mean of 1.84 and 0.07. Approximately normal distribution. You'll know that that tilde, this is called a tilde, means approximately. Huh? Tilde? Oui. Si. Is it really? Oh, okay. Yeah, it's like it goes over like the little, it goes over A, right? Oh, like that? Okay. I'm learning so much. Cross curricular. All right. Coming down to the next one. It says what percent of the laps are less than 1.7? So just checking your answers. If you need me to go through it, let me know. But 2.5%. The next one should be 84%. The next one should be 81.5%. And the last one is 1.98 minutes or more. Any questions about 2, 3, 4, 5?
Okay.
Don't just write down the answer. Understand it. Which one? Number 5. It said, what lap would be the slowest 2.5% of all lap times? Okay. So how would we go about doing this one?
So you go to the right side,
You go to the right side.
and then you find where it would be 2.5% left, which is at 2 standard deviations.
Okay.
And then the time at 2 standard deviations is 1.98. So
Oh, for the thing. Oh, it's 2.5%. Like in the normal distribution curve, which is what he's talking about, this little thing is 34, 13.5, and then 2.5 from there on out. It's 2.35 and then 0.15 for that next one over. When you combine those two, it's 2.5. Does that make sense? Anybody else on 2, 3, 4, or 5? All right, flip the page. Okay. Now here's where you actually like have to calculate craziness. So in order to beat his friend Tom, Mr. J needs to have lap times that are less than 1.72 minutes. Find the proportion of laps that were less than 1.72 minutes. So best way we're going to do this is we're going to say, here's our little curve to show what we're talking about. We're going less than 1.72, right? What's our mean? It's 1.84. Okay. Look at my awesome curve. Boom. Okay. So then we're going to find the Z-score. So we're going to take 1.72 and subtract 1.84, divide it by our standard deviation, which is 0.07. When you plug that in, what'd you get for your Z-score? Negative 1.71. You're going to go to your Z-score table. You're going to find the negative page. That's that first chart. You're going to go down to negative 1.7. You're going to go over to 0.01. And whatever number is right there is going to be your proportion. So that's going to be area equals 0.0436. 0.0436. 4.36%. Okay. Good. Yep. No. Because standard deviation is how far away from the mean. Can you have negative distance? So then you probably wouldn't have a negative standard deviation then. Does that make sense? Okay. All right. Mr. J would really like his laps to be consistently between 1.75 and 1.85. What proportion of his laps were in this interval? Okay, so we're finding the curve and we're doing it in between 1.75 and 1.85. And the mean is 1.84. We're finding this space in between. Okay, so you've got to find the Z-score for both of those things. Find the proportions, subtract the two. Good? So we're gonna find the z-score for the first one. We're gonna find the z-score for the second one. Ooh, can't draw an 8 today. I don't know what it is. And when you do that, you should have gotten negative 1.29 and 0.14. Okay, then we go to the table. Everybody okay with how to use the table? Okay, then you find the proportions that go along with those z-scores. Okay, so the area is going to be 0.0985 for this first one and 0.5557 for the second one. And then you're going to subtract those two. So that's going to be 0.557 minus 0.0985. And that's going to give us 0.4572. Okay. If they ask for the proportions, you're going to give it in decimal form. Yes? Okay. All right, so I still see a lot of people like copying it down. Did you finish up 8 and 9? Did you finish 8 and 9? I see some blank stares. Try 8 and 9. I'm gonna give you just a second. All right, 8, I got, the area is 0.011.
What?
Crazy? Crazy. Remember, it says more than 2 minutes. Yeah? So you should have said 2 minus 1.84 over 0.07. Z-score is 2.29, right? Okay, then we're going to go to the table. And we're going to go to 2.29. We're going to go to the positive guy. And we're going to go down to 2 over to 0.9. That's this guy, right? 0.989. Okay, so down to 2.2 over to 0.09. So I got 0.9890. Since it says more than, I'm going to say 1 minus. Yes. And that's going to give us 0.011. Mathing. You didn't find what? What'd you round it to? Two decimal places. 0.07. Yeah. You're gonna round to 2 decimal places with z-score. Yes? No. It's okay. I'm gonna help you catch up in a minute. What's up? Say it again. 1 minus whatever the number is. Okay. All right. Last one. It asks about the fastest 3%. Okay. Fastest 3%. So what this is asking for my visual people. We want less amount of time, right? Yeah. So fastest 3% is going to be down here. Yeah. Okay. So since the area is 0.03, we're going to go into our table, find the z-score that's according, right? What was the z-score that you found? Negative 1.88. Everybody see that? Okay, so what'd you get? So when we look at this, we're looking for 0.03 in here, right? So that's gonna be somewhere in this negative 1.8 section. Okay. All right, then we're gonna plug that into our formula. And so that's gonna give me negative 1.88 equals, we don't know the value, minus 1.84 over 0.07. And when we find x should be 1.7084 meters. Okay, I see a little bit of confusion. Let's clarify on Monday. How would we feel about doing the quiz on Tuesday?
Wow, that was lovely.
Yeah?
Lovely.
Okay, I need you to do some homework. I need you to do some homework, okay? At least get through the 2.1 recommended assignment. You can do that, okay? All right, bye guys.